In 1958, in a classified meeting room at Kirtland Air Force Base in New Mexico, Air Force officers posed a question to assembled scientists that sounds like the fever dream of a science fiction writer. What would it look like if we could blow up the moon? This wasn't a thought experiment. This wasn't idle speculation over coffee. This was Project A119, a top-secret plan to detonate a nuclear weapon on the lunar surface, creating an explosion visible to every human being on Earth. The ultimate Cold War flex. A mushroom cloud rising above humanity's ancient celestial companion, backlit against the darkness of space. And a brilliant 24-year-old graduate student named Carl Sagan, decades before he'd become the world's most beloved voice of cosmic wonder, helped calculate exactly how to make it happen. The beeping of Sputnik wasn't just a radio signal. It was a psychological weapon that rewired the American psyche overnight. October 4th, 1957. That's the date everything shattered. When Sputnik launched, crossing American skies every 96 minutes, it didn't just mark a Soviet technological achievement. It triggered an existential crisis that gripped the nation by its throat. Amateur radio operators across the country could tune in and hear it. Beep, beep, beep. A mechanical taunt from 560 miles overhead, a constant reminder that the enemy had seized the high ground. For Americans listening to that Soviet satellite pass overhead, each beep felt like a countdown to annihilation. If the Soviets could put a satellite in orbit, what else could they do? Launch nuclear weapons from space? Establish military bases on the moon? Rain down destruction on American cities with no warning, no defense, no hope? The fear wasn't abstract. It was visceral, immediate, and it demanded a response that would be equally spectacular. Newspapers ran apocalyptic headlines. Congressional hearings devolved into panic. Military strategists scrambled for answers. The United States, the nation that had split the atom, that had won World War II, that considered itself the undisputed technological champion of the free world, had been humiliated by a beach ball-sized sphere of metal and radio transmitters. Within months, under immense pressure to restore American prestige and reassure a terrified public, the U.S. Air Force's Special Armament Center initiated something extraordinary. In May 1958, they contracted the Armor Research Foundation at the Illinois Institute of Technology for what they officially called a study of lunar research flights. The vague title was deliberate, bureaucratic camouflage designed to obscure the project's true purpose. Its real designation was Project A119. And its goal wasn't exploration or scientific advancement. It was to study the feasibility of detonating a nuclear weapon on the moon's surface, creating a display of American technological might that would be visible from Earth 240,000 miles away. A cosmic fireworks display powered by the same force that had leveled Hiroshima. This wasn't about military advantage. It was about theater. Pure psychological warfare dressed up in the language of scientific inquiry. A Cold War chess move designed to demoralize the Soviets and reassure Americans, regardless of the consequences. The question wasn't whether America should nuke the moon. The question was whether they could, and how spectacular it would look when they did. Imagine being a respected physicist, focused on legitimate research, and your phone rings with a classified commission that sounds like it was dreamed up by a committee of comic book villains and desperate generals. That was Dr. Leonard Reiffel's introduction to Project A119. Within months of Sputnik's launch, a small team of scientists in Chicago received a classified assignment that would push the boundaries of both physics and sanity. Their mission: figure out how to detonate a nuclear bomb on the moon and make sure the whole world could see it. Dr. Leonard Reiffel, a 34-year-old physicist at the Armor Research Foundation, became the project's lead scientist. He was a pragmatist, a serious researcher who found himself coordinating a study that blended cutting-edge physics with Cold War absurdity. Later, he would describe the atmosphere as driven by an intense sense of urgency, with a lot of pressure to come up with something spectacular. This wasn't a panel of mad scientists cackling over destruction. These were serious researchers, astronomers, physicists, engineers, suddenly tasked with answering questions no one had ever needed to ask before. How high would a mushroom cloud rise in 1/6 gravity? How would nuclear fire behave in a vacuum? Could you hit a moving target 240,000 miles away with 1950s guidance systems? To answer these impossible questions, Reiffel assembled a small elite team. Among them was a brilliant graduate student whose theoretical work on lunar dust and the moon's exosphere would prove crucial to determining whether this audacious plan could actually work. His name was Carl Sagan. In 1958, Sagan was just beginning his career, a young, ambitious astronomer eager to make his mark in the emerging field of planetary science. His assignment? Calculate how visible the explosion would be from Earth. Model the behavior of lunar dust in vacuum conditions. Determine if a nuclear detonation 240,000 miles away could create a spectacle that would restore American pride and Soviet fear. It was, in retrospect, a darkly ironic introduction to space science for someone who would spend his career advocating for the peaceful exploration of the cosmos. As the team dug into the calculations, they identified the optimal weapon, the W-25 Warhead, a relatively small tactical nuclear device with a yield of 1.7 kilotons. To put that in perspective, it was roughly 1/10 the power of the bomb that destroyed Hiroshima, small enough to be manageable with existing rocket technology, but still powerful enough to produce a visible explosion from Earth. The delivery system would be a modified Atlas or Titan intercontinental ballistic missile, the same rockets being developed to reach escape velocity, and with the right modifications, capable of delivering payloads across lunar distances. These were cutting-edge machines, barely proven, now being repurposed to strike not Soviet cities, but the face of the moon itself. And the target? The lunar Terminator, the line between day and night on the moon's surface. Detonate the bomb there, and the explosion's dust plume would be backlit against the darkness, illuminated by the sun, maximizing visibility from Earth for maximum propaganda impact. Reiffel's calculations showed the plan was technically feasible. The technology existed. The physics checked out. But as he produced his comprehensive feasibility study, a crucial caveat appeared in his report, a single sentence that revealed the growing unease in his conscience. I made it clear that my report was a feasibility study only, and did not reflect my personal endorsement of the idea. It was a scientist's quiet rebellion, a way of saying we can do this while carefully not saying we should. Here's the challenge with nuking the moon. While it lacks a substantial atmosphere, the explosion was still predicted to create a cloud rising several kilometers above the surface, although less defined and quicker to dissipate than a mushroom cloud on Earth. So how do you make that visible across 250,000 miles of space? The answer required Carl Sagan to solve problems no human had ever confronted. Picture this. You're a 24-year-old graduate student, excited about studying the cosmos, and your assignment is to calculate the visibility of a nuclear mushroom cloud on the moon. Not the atmospheric composition of Venus, not the rings of Saturn. The optimal detonation point for a weapon of mass destruction on another world. Sagan approached the project with the same rigor he'd later bring to his groundbreaking work on planetary atmospheres. His calculations had to account for factors that existed only in theory. The moon's surface composition was largely unknown. Was it solid rock? Loose dust meters deep? How would the vacuum of space affect the explosion dynamics? How would 1/6 gravity influence the debris plume? He determined that the explosion would create a massive plume of lunar dust and debris. In Earth's atmosphere, a nuclear detonation creates that iconic mushroom shape through the interaction of the fireball with air molecules. On the Moon, the physics would be radically different. The initial flash would be brilliant but brief. The real spectacle would come from the dust. Tons of pulverized lunar regolith hurled upward by the blast, creating a cloud that would rise several kilometers above the surface. And if timed correctly, detonated at the lunar Terminator where sunlight could illuminate the expanding dust cloud against the darkness, Sagan's calculations suggested it would be visible to the naked eye from Earth. A cosmic firework 240,000 miles away. A brief, brilliant flash followed by an expanding plume. A monument to human technological prowess and hubris visible to every person who looked up at the night sky. When Sagan presented these findings to the Air Force sponsors, witnesses described what Leonard Reiffel later called a eureka moment. The brass saw their propaganda victory materializing in equations and trajectory plots. It could actually work. But here's what haunted the project. They were operating on speculation and untested assumptions. In 1958, humanity had virtually no direct data about the lunar surface. Every calculation about how the regolith would react, how the dust would disperse in vacuum, how the plume would behave in 1/6 gravity, all of it was theoretical. Educated guesses based on telescope observations and physics models that had never been tested beyond Earth. The delivery mechanism presented its own nightmare of precision engineering, hitting a target 384,400 kilometers away with guidance systems that had barely mastered Earth orbit required accuracy within a few kilometers across the void of space. The Warhead and its electronics had to survive cosmic radiation levels no nuclear device had ever faced. Temperature extremes ranging from 127 degrees Celsius in lunar sunlight to negative 173 degrees Celsius in shadow. And there would be no mid-course correction, no second chance if the calculations were off by even a fraction of a degree. They were adapting weapons of mass destruction for a mission profile that existed only on paper, using computers less powerful than a modern smartphone to calculate trajectories that would make history, or become the most visible failure in human history. The team produced a comprehensive 190-page classified report detailing the technical feasibility, the optimal detonation point, the expected visibility, the delivery systems. On paper, Project A119 could work. But as the scientists dug deeper into their own calculations, as the initial excitement gave way to sober reflection, a different kind of problem emerged. One that no amount of mathematics could solve. There's a moment in every ambitious project when someone asks the question no one wants to hear. Should we actually do this? For Project A119, that moment came when scientists realized they might be about to turn humanity's greatest symbol of wonder into a radioactive wasteland, and call it progress. Leonard Reiffel saw it first. As the project's lead scientist, he'd assembled the calculations, mapped the trajectories, proven the concept worked. The science was sound. The technology existed. But in his final report to the Air Force, that crucial caveat appeared. His way of handing the military a loaded gun while making it clear he wouldn't pull the trigger himself. Carl Sagan, the brilliant young theorist whose calculations had proven the explosion would be visible from Earth, raised more direct concerns. What about radioactive contamination of the lunar surface? The explosion would scatter radioactive isotopes across the impact site. Strontium-90, cesium-137, plutonium, elements that would remain hazardous for decades, perhaps centuries. What happens when the public finds out we've poisoned the moon? His questions weren't hypothetical. They were warnings about turning a propaganda victory into a scientific and public relations disaster. Declassified documents reveal the internal debates that followed. Scientists worried about contaminating the moon for future scientific exploration. The very dust they'd planned to illuminate with nuclear fire would carry radioactive isotopes across the lunar surface, potentially destroying irreplaceable scientific data about the moon's formation and the early solar system. Humanity's first extraterrestrial destination would arrive pre-poisoned, a cosmic crime scene of our own making. But beyond the scientific concerns, a more immediate fear gripped military planners: the spectacular potential for catastrophic, globally witnessed failure. Think about it. The project sold as demonstrating American technological superiority could become the ultimate embarrassment. Missing the moon entirely, the missile sailing past into deep space while the world watched, would be humiliating. But worse would be a dud. A warhead that failed to detonate, creating nothing but silence and darkness. While Soviet propaganda machines worked overtime, America's grand gesture reduced to a cosmic whimper, broadcast globally, immortalized in failure. And then there was the international backlash to consider. If the plan leaked before execution, or succeeded and triggered global outrage, America would be seen as recklessly militarizing space, turning the cosmos into a battlefield. The propaganda victory would evaporate in the face of worldwide condemnation. By January 1959, less than a year after its inception, Project A119 was quietly shelved. No official announcement, no explanation, no dramatic cancellation order. Just a classified report filed away in a secure facility and a small team of scientists reassigned to other projects. Multiple factors contributed to the decision. Military advisors recognized the public relations nightmare. Scientists, including Reiffel himself, argued that contaminating the moon would destroy irreplaceable scientific opportunities. The technical risk of visible failure loomed large. And perhaps most importantly, there was a growing recognition that weaponizing space could trigger a dangerous new phase of the arms race, with both superpowers turning the cosmos into a battlefield. The project remained classified for nearly 40 years. Then, in 2000, Leonard Reiffel revealed its existence in interviews with the press, shocking historians and the public alike. The revelation came with a footnote that made headlines. Carl Sagan, the beloved astronomer who had spent his career advocating for the peaceful exploration of space, who had written Cosmos and Pale Blue Dot, who had become humanity's greatest cosmic storyteller, had once calculated how to make a nuclear explosion on the moon visible from Earth. There was another twist to Sagan's involvement. In his graduate school applications, the young scientist had mentioned the classified project, violating security protocols in his enthusiasm to showcase his work. It was a mistake that could have derailed his career before it began. A youthful indiscretion that nearly cost him everything. But perhaps the ultimate revelation was this: Project A119's cancellation wasn't a failure. It was one of the Cold War's rare moments of collective sanity. Scientists, military planners, and political leaders all stepped back from the brink, recognizing that some demonstrations of power are too dangerous to contemplate, even in an era defined by nuclear brinkmanship and existential fear. In the end, Project A119 died. Not with a bang, but with a bureaucratic whimper. And that quiet death may be one of the most important decisions our species has ever made. The Air Force ultimately judged the risks, scientific, technical, and reputational, as outweighing any potential benefits. The concerns Reiffel had voiced about contaminating the moon for future exploration, about the potential for catastrophic failure broadcast globally, had won out. The reports were filed away, classified, and the scientists moved on to other work. The moon remained untouched, unmarked by human weapons, pristine as it had been for 4 billion years. For decades, Project A119 remained one of the Cold War's buried secrets, a footnote in classified files that few would ever read. But its legacy lived on in ways its creators never anticipated. The ethical debates it sparked, about contaminating celestial bodies, about the militarization of space, about the line between technological capability and moral responsibility, directly influenced the Outer Space Treaty of 1967. This landmark agreement, signed by the United States, the Soviet Union, and dozens of other nations, banned nuclear weapons and weapons of mass destruction on the Moon and other celestial bodies. It established space as a realm for peaceful exploration, not military conquest. Where once nations considered spectacular shows of force, they now negotiated treaties and cooperation. Where Cold War paranoia had pushed scientists to calculate mushroom cloud heights on alien worlds, a new generation would work together on joint missions, shared data, and collaborative science. Today, as we prepare to return to the Moon through the Artemis program, as we plan permanent lunar bases and use the Moon as a stepping stone to Mars, we do so under the principles established by that treaty, a direct descendant of the ethical awakening that killed Project A119. The Moon remains untouched by nuclear weapons, a testament to a moment when fear almost drove us to irreversible action. When you look up tonight and see the Moon hanging in the darkness, its face marked only by the ancient craters of cosmic impacts, not the fresh scars of human weapons, you're witnessing the result of a choice made in a moment of Cold War madness, and ultimately rejected. Project A119 stands as a reminder that in the space race, sometimes the most important victories are the disasters we avoid. The question those Air Force officers asked, "What would it look like if we could blow up the Moon?" was answered not with a mushroom cloud, but with restraint. The cosmos is vast, ancient, and indifferent to our fears. But it's also ours to explore, not to destroy. And that choice, made by scientists who found their conscience, by military planners who recognized the limits of power, by a nation that stepped back from the brink, may be one of the most profound acts of wisdom in human history. Sometimes the most powerful thing we can do is choose not to pull the trigger. The Moon still hangs in our sky, not as a battlefield or a propaganda target, but as it always was. A symbol of wonder, a destination for dreamers, and a reminder that our reach into the cosmos should be guided not by fear, but by the better angels of our nature. If you enjoyed this story, hit subscribe for more stories where history, technology, and human ambition collide. Thanks for watching.